Hello everyone. So today we are solving a question of JEE ADV 2022 from the topic of fluid mechanics. So let's see how we can solve the question. First read the question. So they're given a open-ended U-tube with some cross-section area which contains water initially, and the water level stands at 0.29 from the bottom in each arm, and the kerosene oil and water-immiscible liquid of density 800 kg meter per cube has been added in it until its length is 0.1 as shown in the schematic figure below. The ratio of H1 and H2 of the heights of the liquid of the two arms is. Okay, so let's visualize this question by doing, okay, let's suppose this is a U-tube like this, okay, and they're given, let me drop as the initial condition. There is water, they both should be at same level because the pressure difference has to be maintained, and we know that what is pressure difference? Delta P is nothing but equal to rho GH. Let's suppose if some atmospheric pressure P is there, so at this point and at this point, we note at same level, same pressure. So this is a very fundamental concept you have always to be remembered. And so to maintain this, the height will be always be same because the density of the water is always same. The gravity is same at both places. So H will be same, which is given as 0.29 initially. Now later what happens in that U-tube, we add kerosene. Okay, let me draw kerosene from another color. Uh, let's suppose this is kerosene here up to 0.1 meter, and for the rest it is again the water which is transparent. Okay, we'll assume. So what happened to water? It has, let's assume that it has gone x meters downward. Okay, we are assuming that water has gone x meter downward, but to maintain the volume it might have risen up to x meter here. Okay, let's suppose this was 0.29. Okay, so and this was 0.29. Okay, so if it has gone x meter from downward from here, then it must have risen x meter upward from here. Now if we again measure the pressure at this point, okay, at this high level, so it again should satisfy that the pressure at those places should be same. Okay, now let's write the pressure difference equation, that is rho GH. So for kerosene, the density of kerosene is mentioned as 800, gravity is same for both, and its height given as 0.1. Okay, and for water it is 1000 into G is same, and we are assuming that it has gone x meter below, so it will be 0.29, which was initial height, minus x. Now this should be equal to, if we go for this side, this should be equal to 1000 times 0.29 plus x, because we are assuming that it will go x meters above. Now cancelling G from all the sides, G we haven't written here, and 800 into 0.1, it is nothing but 80, plus 1000 times 29, this will be equal to 290, minus 1000x is equal to 290 plus 1000x, cancelling 290. So if we give 80 by 2000x, okay, sorry, x is equal to 80 by 2000, cancelling this, 8 4 2 and 4 is 50. So if we multiply 100, I mean 50 both, sorry, 2 to the both sides, so it will be equal to x is nothing but 0.04 meters. Okay, so we get this calculation. And now what we have to do, so the net height h1, what is h1? H1 is equal to 0.29 minus x plus 0.01, and what is h2? It is nothing but 0.29 plus x. So what is 0.29 minus x? So 0.25, it will be equal to 0.35, and 0.29 plus 4 is equal to 0.33. Hence the ratio of h1 by h2 is nothing but 35 by 33. So we get our option B as correct. And let me write the answer here. It is nothing but 30, sorry, option B. Okay, thank you.